All right, so this one, these are all accelerated ion problems, okay? We're going to use two different things, right? One of them is either work is charge times change in electrical potential, or the same exact formula, right? Potential energy is Q times the electrical potential, okay? Either one, either one. I tend to think in terms of this, okay? Or it really is a difference in potential. But anyway, what we do is we just say, okay, that potential energy becomes kinetic energy. Kinetic energy is 1/2 mv squared. Okay, and we just set these guys equal. So let's see, it's a proton, right? Okay, you're going to look this up in your data packet. So inside the front cover of your data packet, I'm flipping the pages now. Okay, on the it's the first numbered page. It says fundamental constants, and near the bottom you'll see the elementary charge, right? That the charge is E is 1.60. They don't put the 2 on there, but I do. Times 10 to the minus 19th coulombs. So that's the charge, right? And it's positive for a proton, right? And then the mass of a proton is 1.673 times 10 to the minus 27th kilograms. Okay, so you look that up in your data packet. Look it up on page 1. Practice finding these in your data packet so you're not leafing around madly or panicking or what do I do with a proton, right? You got to look it up. Look it up on page, what does that say? Oh, page 1, page 1. Okay, that's a 1. Okay, so now really this is not so hard. So let's see, I'm going to just say Q times electrical potential is 1/2 mass velocity squared. Don't confuse the V that is potential with velocity, because that would be silly. Okay, so here we go. 1.602 times 10 to the minus 19th coulombs times 3.7 joules per coulomb is 1/2 mv squared. So let's see, 1.673 10 to the minus 27th kilograms times v squared. We're just trying to solve for v. So I'm going to go 1.602 e minus 19 times, by the way, the data packet does not have the 2 on there, but I memorized that so long ago. All right, times 3.7. Okay, and now let's see, I want to get v, so I'm going to take that whole thing and go times 2, and then I'm going to divide by 1.673 e minus 27, and wow, that's a big number. Now I'm going to square root that. Raised to the 0.5, and I get 26619. Now we only have 3 sig figs, so I've got to go. Let's see, scientific notation. 1, 2, 3, 4. So it's 2.66 times 10 to the 4th meters per second. There you go. I think we're good. All of these will be sometimes there's protons, or sometimes there are electrons, right? You're going to have to look up the mass of an electron in your data packet. The charge on either one is the same. The fact that an electron is negative doesn't really matter, because I'm just saying it's through a difference in voltage. So presumably it's a difference in voltage that accelerates it, right?